Hi everyone. Today we are going to start design patterns, CQRS and Saga. Till now, due to a trainer unavailability, unable to take this session. So we have a trainer Upsar. So throughout the session, he will guide you for all the things. Upsar, you can take the session. You can start, guys. If you have any questions, please ping in the chat box because CQRS and Saga is kind of a tricky part. So please hold your questions. Lot of things we will discuss as part of the design pattern. Even in interviews, also this is a common questions will happen. So he will take the session right now. Before starting, any questions, guys? Say yes or no so that we can proceed for the next. Either in the chat box is also fine. Are we good? Yeah. Thank you, guys. Sir, you can take the session and you can start. Yeah.
Hello all. Good morning again. Yeah, myself is Apsar. So I've been in software industry almost 10 years. So yeah, I have worked on a couple of projects, different domains as well. Yeah, so that's sort about my quick introduction. So today's topic is CQRS and Saga design pattern, and you all are aware of this that it's damn sure question everywhere. Wherever you go for an interview, you have cloud microservices experience, and yeah, this is a must damn question that they'll ask, right? So yeah, we'll start with the basic things, and then we'll move on to the coding session as well, live coding session with CQRS and Saga design pattern. So let's start with today's agenda. Yeah, so today's agenda is we'll learn about a few basics about microservices, and then we'll move to what are events and what is event sourcing, and then we'll understand what is CQRS design pattern, and then we'll see how we can achieve this CQRS design pattern implementation with the Axon platform. So these are four topics that are mainly targeted for today. If time permits, we'll see about what are the transaction communication problem that we have with microservices, and then we'll see the Saga design pattern implementation as well. So as of now, we'll target these four items, and then we'll move on to the next topic. Okay. So let's see. So what are microservices? Basically, there are two things that we go for microservices. One is when we have a monolithic application, which is a legacy application that we want to divide into microservices. That is one way that we go to microservice. Another one is like when you are implementing the latest project, so directly you will implement with microservices. So yeah, so you know the problems with my monolithic applications that I don't go in detail about it because this last session for the comparison between monolithic and microservices, you all are aware that what is the difference, what the good things we achieve with microservices or monolithic applications. So I'm not going deep into about it. So I'm just telling like two things, that is converting or migrating your monolithic application into microservices, or you will implement directly your new project in microservices, which will give a lot of benefits to us and good maintenance, everything that you know the benefits of microservices, right? So how do you divide your monolithic application into microservices, right? That is one challenge you have when you start migrating your application into microservices. Also, when you start implementing new microservices. So dividing your project into microservices is the biggest challenge, right? So basically what you do, you will see the nouns in your project. What are the nouns? If I take a banking application, what are the nouns you have in your application? Those are like account, and account will have address, and your bank will have branches, and also you have circles. Different terminologies there in your banking system. You will have head office, you will have employees in the bank, you will have customers in the bank, you will have accounts. So all these are nouns that are part of your banking application domain project, correct? So in such case, you have to divide this whole nouns of your project into different microservices. So that's where challenge will come. So that's where we divide our project or requirement into subdomains. So your domain is your banking application, or it can be automobile industry, or it can be a beverage company project, that is a domain. And you will have different domain. You will have healthcare domain. So inside that domain, you will have subdomains to divide, right? To different nouns, as I said, the several names I took for the banking application. So those are like subdomains. So when you divide your noun, when you divide your project domain into microservice, you need to must consider this one. Each bounded context becomes a microservice. So what is bounded context here, right? So a bounded context is, as I took one example of account, right? So when I took account as my microservice, in such case, my microservice should be responsible to implement only related to accounts, right? If I take example of address, so my address microservice should only do the operations related to my address, correct? So means it should have a boundary. My microservice should have a boundary to its context. So that's why we need to consider when we divide a microservice, it should have a boundary towards it. My account should not do a transfer operation, right? If I transfer an amount from one account to another account, so the transfer action my account microservice should not do. The transfer microservice should do it, right? So my account should not have information about branch, create branch, delete branch. It should have only related to account creation, credit amount, debit amount. These kind of operations I should have as a my REST APS. When I say operations is REST APS, correct? And what is another one is like we should have ubiquitous language. So what does that mean? So what are the different categories that we have in software industries? Like one business who gives a requirement to us. So the roles are like product owner, business analyst. So you might have these kind of roles in your companies as well. So those are like business category, and you will have a development category where we all comes into the picture, developing an application and all. And then once you develop an application, you will have testers who do testing and who certify, who sign your application is ready to go for production. The last one is like operational team who actually deploys your application into maybe in house or in maybe in the cloud. So we'll have different deployment strategies, right? So there they'll deploy, and whenever some production issue trigger, so they will inform us like what is the issue. They'll help us in debugging. They'll do a lot of actions. So these are a few basic parties. Those are in the complete project journey, right? So whenever you choose your language, when you are developing a microservice, your language should be understood by all these parties. So I have taken four parties. There may be other parties involved in this, like managers and all. I am not taking this. These are like few four basic categories that we have uh, in our projects, right? So these four should understand what you are saying. So consider that when business said, I need account, I need branch. So whenever business says account, because it's like communication with the customers, right? So it's like simple language. That's why I took it as a ubiquitous language. Means it is simple, should be simple, understood by all the parties, like these four parties. So when I say account, my dev team also should understand, my testing team also should understand, and my operation team also should understand my language. So When I say branch, my dev team should also understand test team and operation team. So when somebody tester said there is an issue in the account creation, there is an issue in the credit amount. So this language of tester should understand by the my business team also, and also operation team. Everybody should able to understand. That's why we should have a layman simple language that is understood by different parties in our projects. That's why it is very important. It might be like you can say easy, but when you consider that you have created uh, some other name of your class, generally these entities, right? What are the class objects which we store in the database? Basically, business's account. So what you will do, you will create an account entity in our entity, and you will create the repository packages. You will create service, REST layer, and all. So it is easy to understand for the developers. Consider that you have taken different name here. Account, instead of account, you have taken XYZ, and business is telling about account. So that account you are mapping with XYZ class. That's very difficult to understand. Consider that I have written code. After 2 years, somebody joined newly, and the business saying account, and you are saying the class name is XYZ. So it's very difficult to understand, right? So that's why we should have a same language of classes everywhere, and also test script should be related to the account only, right? So this is about the language that we should use in microservices. I'm telling like which is like in more like software way of living and developing our microservices. The remaining comparisons you will get in Google. You can just type what is difference between microservice, monolith. That information will get on Google. I'm going beyond what Google says. Okay. And also, whenever you develop you implement your domain, right, like banking domain or beverage domain or healthcare domain, so the requirement is like should be a, storytelling. Okay, it's like a simple storytelling. Business should tell your requirement as a storytelling, like how generally you will have Jira, other tools, right, where it should be like a layman language that should explain. Okay, based on that we'll create our entity objects or value objects also, we say it, right? Account, address, branches. I hope these four I went in detail. I hope these are very clear. So let's move on to the next one. Okay. I just I'm starting with the simple some terminologies. Please concentrate on this terminologies, because these terminologies will use when we are implementing CQRS design pattern. Okay. So these are few topics that we'll understand here. Uh, so events and event sourcing. So when you have publisher subscriber kind of concept, right? So there you will come with terminology kind of this events and all, correct? So what are events here? So events are object that describe something that has occurred in the application. So generally in your application some exception came, that also you call it as event, right? And also some action, like you have created an account. When you create an account, some event occurred in your application, so you need to give it to somebody else. Like I have created account, I'm generating the event. So the publisher will give the event, and subscriber will receive that, hey, some account is created, I'll do some other process, I'll store that account in database, I'll do some other actions that I want to do. So those are like events, right? So event sourcing, what is event sourcing here? So consider that you go to one pizza shop, Pizza Hut or Domino's and all. So you go and order uh, one pizza with some cheese and all, some vegetable pizza you have ordered, and you asked them to add the cheese also. Then after that, you are telling that I want one capsicum pizza also. After that, you told I want some non-veg pizza. But after ordering non-veg pizza, you told like I don't want capsicum pizza. So you are removing the capsicum pizza. So you have done four events. First vegetable pizza, and then capsicum pizza, then non-veg, and then fourth one you are asking to remove also. Means these four actions that I need to store in somewhere, so that when you finalize your order, you should be understand that what are the requirements that customer told while giving the order. So all these four steps need to be stored somewhere. That is nothing but event sourcing. Okay, this has the information. So event sourcing defines an approach where all the changes that are made to will be available in my event source. All the four actions will be there. Okay, event is something that happened in our application. Event sourcing is that I want to store all the changes happen to my application. Okay, as I said, event is a object, right? Are stored in a sequence of immutable events to a event store. Okay, event sourcing is nothing but all the events that are stored in the event store. My event store will have the information of all the my events. Somewhere I need to store, right? So that my subscriber can receive it. Correct? So those are all stored in the sequence of immutable events. Means once you generate an event, that should not get changed. So when something doesn't change, that we call it as a immutable, right? So events, once you create an event, that event should not change. And you have created 10 accounts. So you'll generate 10 events. Those 10 events should be in a sequence of how you have created. So that's why I told like as stored in the sequence of immutable events in the event store, right? All these four actions which I told about pizza, those are stored in the event store. Okay, as opposite to storing just the current state, it doesn't store the current state. As I told, like capsicum pizza we removed right at the last, it doesn't store only the current state, it stores the information of previous states also. Okay, these are about simple terminology about event and event sourcing. Just have your in a mind so that the next topics which we tell, it will be easy for you to understand. Okay, so let's go to the CQRS design pattern. Okay, so CQRS is a software design pattern that stands for. So what is CQRS design pattern? Abbreviation is command. C means command, Q means query, responsibility segregation. Okay, I'll tell in detail about what is about each word that are in this CQRS. So command, query, responsibility segregation. It's telling about some segregation. Okay, further to our microservices, will divide our microservice into based on some domain objects that I'll tell you in detail with diagrams. So there you will get some more understanding. Okay, CQRS suggests that application should be divided into command and query part. Okay, so I'll go to the next slide to explain you. Okay, so I'll come to this previous slide. These are like definitions. I'll go like why we need to go for CQRS, right? So in typical way of application development, we'll have a user. Sorry, 1 second. So what we have is like we'll have a user and we'll have on microservices. We'll have a DB which stores our information. This is typical flow of our microservice implementation. Okay. So when a user hits account microservice where he is performing a verb, is performing a operation called create account. So my create account will be stored here in my account database. Once I create, I need to visualize that response, right? How I have created. So I'll create a get account, and I'll have a put a operation also where I need to update the account information. Okay, just stick with this some kind of theory. So we'll go to the coding as well, because this is like we need to understand why, what, and how, so that we'll get more understand. You can directly go to the interview and you can tell what is CQRS. So I'm just that's why I'm taking more at theory point. So I'm telling very layman words. So try to understand, try to concentrate here. So I have an account microservice and account DB where I store the information. So I have implemented my post operation which I create, put operation to update, delete my account, and get account information. So I have done 4 or 5 my all REST APIs created here. So if I take a e-commerce or if I take social media side like Facebook and all, right? So when you create account, right? When you create a Facebook account or Twitter account, so in general, once in a life, we'll create only one account, right? We'll not create daily accounts in Facebook or Twitter. Once we'll create one account, but we'll see the feeds on at least once in hour. We'll see. Definitely, we'll open Facebook or Twitter, something that what is the latest information, who is putting what post, am I liking the post, Once I put some post, is somebody else liking my post or commenting, so we'll have that eagerness to see, right? So we'll keep loading our feeds and all. We'll keep refresh. We'll open the app. So in lifetime, once in general, people create only one account, but in case some people have, they'll create 2 to 3 accounts in their lifetime span. But here the create of Facebook account operation is like once in a lifetime. But you will do get operation or delete operation. Mostly get operation will do like uh, uh, once in a, I mean once an hour per day. So it is like you are doing a lot of get operations. You are person only one doing at least once an hour. So there are millions of billions of Facebook users or Twitter users, right? So they will do also do the feed operation, like get operation of what are my feeds and all. So here the create operation is like uh, very less time you use, right? So when you do get operation, you will do a lot of time. So in the same way, when you create an account in the bank like ICICI, SBI banks, or HDFC bank, so in lifetime we'll have only one account, but you'll check the balance uh, once in a week, something like that. But you'll do UPI payments, right? Like you go out, a lot of people do UPI payments like 10 rupees to some 1 lakh, and also we'll do a lot of UPI payments. So when you do EPM payment, also a get call will go to check your source account that you have sufficient balance to check your payment is applicable or not, right? So still you do get call. So here account, my creation of account and updation of account is like uh, once in a lifetime, very rarely. So you will change the address of the account, right? So that's like when you change from city to city, you'll change the address. These are like very rarely you do, but you do the get operations a lot. So consider if I'm doing get calls continuously, like millions of users doing get calls, but somebody else who is sitting in my bank, who is a bank manager or some clerk, some PO of the bank, is doing creation of our account in their database, because we don't do account creation, right? They'll do and give to us. So why my get operation should impact my creation? Because when you do millions of users are getting the information about their account, my create account will have impact, right? So like creation of Facebook account also will take some time, because you are using the same database and you are using the same microservice, account microservice, to create and get information also. This is like unnecessary, you are burdening your creator update operations because of your get operations, right? So just to avoid that, why not we break my get operations into separate microservice of account, and all my remaining like put, update, create, all those actions should be in my separate microservice. So uh, you can ask me like, hey, you told we divide the microservice into our entities like nouns and all, and you are telling again further to divide your single account into two microservices again. Yeah. So to have a better performance, right? Like in real time, what we need is like performance is very, very much important, and accuracy also. So that's why to divide my account microservices again into two microservices will give the benefit of uh, not burdening my create operations, right? So because of you do millions of get operations here, my account microservice, where it is running in EC2 or wherever the cloud or wherever the instance it is running in the cloud, so that will get affected. The RAM will be increased when you do multiple operations, right? And also it will burden on DB. It will keep doing the get calls and all. With connection pool, your connection pool also will get burdened. So your create operation may affect, right? Bank account creation is like very must important. If it start failing there, uh, when you do, you may get sometimes like when you do get call, your balance doesn't come. It is fine like 1 or 2 times, but when you create an account, if something fails, right? So there is a problem. So the reputation of the bank, Facebook, social media account, that will get affected, right? So that's why we'll further divide this account microservice into two microservices. Okay, that's where the operations which I told, right? Create, put, delete, where you change the state of your uh, object, right? Those are called command. So those are called commands. Here, command is not something if I go here, now you will understand what is the definition of command. Okay, command means it is an intent to add a new or alter a existing or delete an entity. So I have divided microservice into two, right? One microservice which is responsible for creation, means adding new, or alter existing, that is put operation or patch operation that I do, and delete operation which I delete account and all, something like that. So all these are called commands. You are giving a command to create new or alter the existing one, and deleting the my account object. So these are all state changing operations that you have in one microservice, that is called command microservice. I hope you are getting the definition now after I explain the diagram. Okay. Now other microservice which I told is query microservice. Queries express the desire of the desire for the information. So what you do when you do a query, you want to understand what is there in your database. What are the new fields that has come? What is your account balance? All those information you do by query. Query is nothing but your get operations. You do a get call, you will have the information what is stored by your command, right? And generally a specific representation of the state of your system. So queries will not alter or add the new thing. It will read the information what is there in your database, like get calls and all the get calls will be in there my query microservice. All my command calls like create, update, delete, all the operations will be there in the command microservice. Now account microservice will get into two microservices, command microservice and query microservice. Now you should be understanding this line now, right? So command query responsibility segregation. Okay, segregate your microservice into command and query, which will have their individual responsibilities. Clear now about this line? So this is why the name it call as CQRS design pattern. Separate your commands and queries into two microservices, which will have their own individual responsibilities. So segregate them. Okay. So there are two ways to implement this CQRS design pattern. Okay. So where you can have single database or you can have two databases. So let's discuss about single database first, and then we'll go to two databases. So when my account microservice, uh, these are like Lehman diagram which I have given. You can apply it for banking domain, you can apply for any other social media domain and all, e-commerce as well. So users generally they call the presentation layer, then under presentation layer we'll have commands which are nothing but my REST APIs and all this, like get put, sorry, put, post and delete, and here I will have my get operations. So two microservices I'll divide. So what is domain object, I'll come to this. And yeah, so I'll have command microservice, then it will connect to the same database where my query microservice also connects. So that's why I say like single database, commands use domains, queries use database. Simplest of three. Okay. So what is domain? I'll come to that line. So I'll explain in the in the coding part when I do, because it's coming more of theory. Okay. So other way is like I can have two databases. One database is for commands. Whenever I create, directly store that through my repository classes into my write DB, and after my whenever I do a queries, I should have I should read from the read database, right? Here, when you create your database, if I go back here, when you create your database, you will have the data available in the same database, and you can simply do a get call to see your data through queries get APIs. Here, if you see here, here it is different thing, right? So you have two databases. Whenever you create, the data should be persist here, right? In the read database also. That's then only when I do when you do the get call, then only you will see the information. You create the account here, that is stored here. But when you don't have that account created in this read database, you cannot see in the get call, right? So that's where we should have a sync between, once you generate a right data, some row in the right database, immediately that information should be there in my read database also. Okay, so if you see these 5 lines, right? Read and write databases, two separate databases. Commands use write_db to write the information. Queries use read_db to read the information. So what another thing you should have is like, all my write database information should be there in read database. That's where the events comes into the picture. So something you store in write database, immediately that information should be there in my read database. That you can achieve with events. That's called eventual consistency. Means all 100 rows of my read database should be there in my read database else also. That's why the consistency word I have used with a very fast magnitude. Like it, immediately once I create here, immediately that information should be there in my read database. How can we achieve? I'll show you live in the coding session itself. Okay. So there are two ways actually. There are multiple ways to sync between this database. One is like, you write a scheduler. Okay, in every 1 minute you trigger a scheduler which will take the latest information from my write db and stores in my read db. Correct? That is one way. I'll run a scheduler in my some scheduler service, takes all the information from write db and insert into my read db or update into my read db. That is one way. The second way is like, you have some Kafka kind of thing. You push a message once you write in the write database, push a message and store in the read database. The third one is like event way of doing. So we'll choose the event way of doing. And what is the benefit of using here? I'll explain you. So better than the schedulers, better than this Kafka and all. Why this is event way of doing is better? I'll show you that. Okay. So that's where I'm taking the example of my banking system. That's why I have divided account microservice and query microservices. Those will have independent databases. I can explain you with a single database also, but it's very easy, right? So why not we go to a difficult way of doing it? That's why I have. You can try with single database by your end. I'll explain about difficult path where we'll have two databases which individually connect to my microservices. So all this, as I said, told like create, update, delete operation, you do the command, and get operations you do with the account microservice, query microservice. Okay. So one thing I told, right? So I should have the sync between my write and read databases. Once I create some account here, immediately my whatever I insert in write database should immediately come to my read database. I have told like, we'll use the events concept. So you can write the code by yourself, but also this one third party vendor called Axon. So this Axon people have given one easy way of, you just add a dependency instead of writing your scheduler operations, instead of writing your Kafka, instead of writing your events concept and all. These people have written already a library. We have a dependency for that. You can simply take the dependency, add in your POM file. These guys will do all the migration from your write database to read database. Okay, we'll achieve that operation with Axon platform. Okay, we'll see about what is Axon platform and how to install it and all. Then we'll go to integrating this Axon platform with our microservice. Okay, so we'll see about some theory and I'll explain you like how to uh, download this, set up this in your local. Okay, so what is Axon? So Axon is a platform that consists of Axon framework and the server. Okay, Axon will have a framework, means a set of classes, set of annotations, interfaces, all those stuff is nothing but a framework, right? So we bundle into a jar file, and that jar file can be used. Like you have Commons util, Apache Commons 3, those are all we have, right? Those are called frameworks. You bundle your all common logic into one library, that is called framework, like how we have Spring and all. And they provide an Axon server which will maintain all your events, all those kind of stuff. Okay, So Axon, another benefit is like Axon framework is developed on Java. So we don't need to much worry about what language it is using. So it's developed on Java. You can go to that classes and you can see like what is the logic they have implemented if you want to learn deeper into it. So they are developed on Java framework only. It's simply building the event-driven microservices that are based on CQRS, event sourcing and domain-driven designs. Okay, so domain driven, you know, right? So your application driven from the domains. So what are domains is nothing but you will have account domain, you will have address domains, you will have different domains, right, in your application. So those are like domain driven designs. So your application driven from the domain. And event sourcing, which I told, like once you perform some action, some event occurred, so my subscriber will take that event, they further proceed about how to use that event in their application. Okay, so Axon service out of box message router event store that requires no specific configuration. Literally, you don't add even a single line your application YAML and all. You just add the library, it will do everything for you. So what is everything? The migrating your write database information into read database. It will do lot more. So we'll taking one uh, benefit of it. Okay, like which is migrating the data from write to read databases. You'll understand more about it when you come for a Saga design pattern about the what is the powerfulness of this Axon platform. Okay, so uh, there is Axon server. You can directly search in the Axon server, and you will land into this Axon website. Then once I click on this, uh, let me go to this. So once you go to the link which I shared there, so you'll go to this downloads folder, and then here, if you see here, Axon server executable jar. Okay, you have a Docker also. You can choose a Docker way, or you can choose a jar file because it's built on Java, right? So you can directly click on download. So it will download a library in your download folders. So once it is downloaded, and you can simply go here. So you can see that I have already uh, downloaded zip file here. So what I'll do, I can simply extract here, extract all. Okay, download the latest version. When you click on latest version, it will download the zip file. Will run a executable jar file. Where it is, I'll just show you. So here my extracted folder is available. I'll go to here Axon server. The version is 2023 2.2. Open it. So you will see here. If you see here, the third one is Axon server .jar file, executable jar file. You can simply run this so that your server will be up. Okay, how we have embedded Tomcat, right? When we run our jar, embedded Tomcat will up, right? So like that, they have also built a inbuilt server in it. Okay, before that, what I will do, I'll share you this config folder also. You just add this config folder inside your server folder. Okay, you just add this config folder. It just has one Axon server. I'll just open this. Okay, you just have it's a default port is 8084. If you still want to change to different port number, you can still change. That's why I have added. Basically, you no need to add this. I just have added that to make you understand that you can still change the default port to how we have 8080 for Spring Boot, right? Like that, they have 8024 as a default port. If you still want to change, you can change it, and you can just give some other metadata information here. Default is localhost. If you want to give your own IP address where you host in your cloud or wherever you host in your in-house servers, that details also you can give here. Okay. So what I will do here, I'll go type cmd. Okay. What I will do, simply java hyphen jar axon server dot jar. Simply how we run our Spring Boot jar files, just run it. So it takes a few seconds to start our Axon server. So it internally uses how our Spring Boot default, they use Tomcat, right? Like that, it also internally uses Tomcat server. They simply bundled our, how we bundle our Spring Boot microservices jars, right? Same way they have done as a framework. So the company name is like Axon IQ. It's developed, who developed the Axon server. Yeah, now it says like started Axon server. So what I will do now, as you can see, like 8024 is like Tomcat port. Let's go to the browser. What I will do, localhost 8024. Okay, this is my local setup. This is, they are offering even these are like community version. They'll offer enterprise version also. So once you type localhost 8024, right, this page, you land into this page. This is Axon server. You simply click on finish. You are seeing a finish button here, right? Where I am hovering it means you are setting up the configuration of this. Means you are ready to use the Axon server. So click on this. It has finished all your configuration setup. You can see, right, whatever the details I have given in my config folder, those are visible here. Okay. So this about setup of Axon server. So how do we utilize this? We'll see this. And yeah, which I told commands, right? So all the command information will be available here. Queries information will be available here. You can search all your events here. Okay, right now we don't have events. Once we run our application, we'll see the events as well. Okay, this is the I have given all the setup here. You can get from this information. Okay, as I told, right, domain. So what are the domain? So where you have your uniqueness, like your nouns, right? Like account is one domain, one subdomain of your microservice, right? Account. So this Axon provides some terminology. Okay, related to your account. So what you do about account, you will create account. That is first action you will do. What you will do next, you will credit amount, right? That is my second operation. My third operation is like debit amount. So these are like these four actions that I do on my account object, right? Account is my entity object, which is it's a stored in database, but there are several operations that are happening on my account object. Those are like create account, credit amount, debit amount. These are all like several actions that you do on your account. So these are all, you combine it, whatever the actions you are doing, combine it into one aggregate. Aggregate is nothing but a couple of things that you do on your one, like you do aggregate operations on employee object, you do aggregate operations on department, and also student, all this on certain, like you do sum of the salaries of the all the employees in certain department, or number of employees who are working on count, you do, right, on department. So this sum count, all these are aggregate operations, right? How do we in Java 8 and also in database, and all these are aggregate operations on you are doing on certain uh, noun, which is like account, employee, student. So all you group into one class, means aggregate all the operations on your domain object, which is account or student, employee, all this count, sum, you aggregate into one class. That's what it is called, aggregate. Okay, I'll show you in the coding in detail about, you'll understand detail about that. So I'll just explain about the theory. So aggregate is an entity that always kept in consistent state. Means uh, you run count, or you do sum of the employees 100 times in that in that current state. You will have consistent data only, right? Like you have 100 employees as of now, you will do the sum of the salaries of the employees. It will 100 times you run, you will get the consistent state only. when new employee added, it will add the new employee salary also. You will get a different state, means different some of the values, some of the salaries, right? So that is nothing but aggregate. You group all the operations. So this follows the ACID property, right? ACID properties: atomicity, consistency, isolation, and durability. So I don't want to go much deep into this. So you already aware that what are the ACID properties. Okay. So these aggregates are like building blocks for designing my CQRS based application. Okay. And typical source of events is aggregate. So when you do create account, when you do credit amount, when you do debit amount, so you are performing some actions, right? So all those actions will be available in my aggregate class for the account. So when you perform these actions, as I told, like events are nothing but some actions generated in your application. So what are the actions? Are nothing but create a account, credit amount, debit amount. So these are my actions. So the source of events is nothing but what are the operations you do in your aggregate class. Okay. So this is nothing but my diagram about how my commands and events are handled here. So I'll just simply give you a small explanation here. Then we'll go to our coding part to understand more about it. You'll get more about this information there. Okay. So in generally, what we'll do, it's like we'll have a UI. So you do a perform a command. What is command? You create an account. So once you create account, so somebody needs to handle the creation of the account logic, right? You do create account, and you want to add some more information. You have to generate some uh, your entity class, and you save in database. So the initial once you trigger it, now you take the command nothing but create, update, delete, patch, create, nothing but post. So when I say the command, you just keep in your mind that these are the 4 operations that we do. Okay. When I do a command, then command handler will take my command, and it will store in my repository. So what are the domains? Is nothing but my aggregate classes. So once you store in your database, what you will do is generally generate event where you store it in your right DB. Okay. So when you generate event, it will go to event source, where I told like event store will store all the events. So when you generate an event, there is nothing but publishing. So somebody has to subscribe so that my events can I take, and I can write into my RedDB also, or I can do some other actions which I want. So you raise an event, then you store in your right database. The same event which is generated will be stored in my read database also. Okay, how we do that I'll show you. Okay. Okay. So now, what do you say? Shall we start coding session uh, in the next session, or you want to continue? You can update me in the chat. Uh, I'm okay with anything. So if you want to start coding now, we can do coding now, or you want me to do in the next session? Because I have gone a little deeper into what is the terminology here, because coding is easy, right? We can see multiple times and write the code, but understanding concept is very, very important here. So it takes a couple of time to even write the code also. Like it might take 1 hour or 40 minutes to write code also, because whatever I have explained, right, all those things I need to implement also. All this whole diagram which I am showing here, I'll implement. We'll have different classes and all. You can let me know if you want to uh, continue with coding, or you want me to have in the next session.
Uh, Thank you, Absar. Guys, it's secure. It's kind of a tricky, right? So everyone knows how it is there. So better we can plan for the next session, maybe for the coding part. By because it may take another 1 hour. Maybe by 1 o'clock will happen. So you guys also need to digest about this theory part. So we are planning next session on the either Saturday or Sunday. Maybe we will send you an email to you guys. Any questions as of now? So that we can close our session today. If any questions, yeah, you can ask Apsar, so he will clarify your queries. Ganesh, Sunil, Chandan, please respond.
No, so fine from my side. I'll go through it and probably in the next class. Next
Uh,
question.
Sorry, come again.
No, I said it's fine for me
Okay.
now.
Okay.
Yeah. But thanks for the presentation. It's good. It was good.
Yeah. So meanwhile, you just go through. I think recorded video will be available. I'm not sure. Maybe I'll check with the admin team. So you can go through the terminology. So directly, you can see the video multiple times because all these are new. I feel like you might not have come across all this terminology. Because when you implement these kind of things in your real-time application, you will come to this kind of environment. So because see, from one microservice I can do REST template call to another microservice, right? Yeah, that we do in our real time. I'm not denying like we should not do, but still these are like event-driven applications. It means your event will play a crucial role between communicating between your microservices. It is like everywhere it is there, right? If I take an example, you have some food delivery app, so Zomato or Swiggy. So they don't do keep on REST template calls between the restaurant to the delivery team and all. What they do simply, they will accept your order. If order is available, they just generate an event. So event will be there in your restaurant. Event will be there in your who are the delivery, right, delivery guys. So all this will be subscribers of your published event. So these are like all event driven applications. So now very rarely we use, I mean, it depends on architecture of your application where we need to use a REST template, where you want to have the response immediately after you call the another microservice, then you go for REST template. When you don't want to have the response, then you can go for event driven kind of applications. So you can, it's like you just need to go through multiple times on this video, so you'll understand what is command, what is domain, what is query, what is this Axon platform. You just download Axon platform server and all, start your server, just play around it in your local, so you'll get some idea about it, right? So then next session we'll do about coding. I'll start from scratch and we'll create application, we'll write every class in hand in our session itself. I hope I'm clear about it.
Yeah. So this one question might not be absolutely related to it. Like you just mentioned about the REST template. Have
Yeah.
you seen RPC calls are being made over the REST call? Like, what are the advantages? Like, have you seen that in real life project? RPC, remote procedure call.
uh, right now I have not came across about that kind of calls actually.
Okay.
Maybe I'll let you know if with other projects if they are coming that
Yeah,
kind of.
yeah.
Yeah.
Yes, because I was reading about microservices. I thought people are now making RPC call between
Yeah, even I
services
heard,
rather than.
yes. Yeah, even I heard that. But in till my projects I have not used, but I have heard about these RPC calls from quite some time.
Okay. Okay. Yeah. Thank you.
Yeah, no problem. So you go through this as I told, like these videos and all again, once again before you come to the next session. We'll do hands-on CQRS. Why I'm stressing more CQRS is like if you understand more the CQRS, right, then Saga is like easy for you. Okay, this complete Saga design pattern is dependent on CQRS only. Okay, first we'll
Okay.
develop CQRS. On top of CQRS, we'll develop Saga. Okay, these are,
Yeah.
there is a
Sure.
dependency between them. Yeah, yeah. Are there any questions on this topic till now? Whatever we have discussed.